So now we will see, see, last time we have seen the von Neumann stability analysis for the Crank-Nicolson. Now we'll see the stability analysis for the heat equation. That we have already observed, that we know that the heat equation, this the FDM scheme for the heat equation will be stable if that ut equals to uxx square was there. So this is stable if r will lies between 0 to half. This we have already seen from Lax-Richmond theorem. Now we will do the same for the von Neumann stability. So let's first write what is the finite difference scheme for the heat equation. Yes. So the finite difference scheme for heat equation. Yes. So it was u I n plus 1 is equals to r u I minus 1n plus 1 minus 2r u I n plus r u I plus 1n. So in the same way we can write u I n plus 1 bar equals to r u I minus 1 n plus 1 minus 2r u I n plus r u I plus 1 n. So the subtract these two, will get error at n plus 1. This equals to error I minus 1 n plus 1 minus 2. This way 1 minus 2r into error I n plus r into error I plus 1n. So this we are getting. Again we will write the same. We'll approximate the error. We'll write this error I n plus 1. This we can write. So this from the von Neumann stability analysis tells me that we will substitute error I n plus 1. This would be so this would be, I'll substitute this for solving this, for solving, because see for solving this we are applying the finite Fourier series here. So as I have already told that since in the error term the sum was there, but we are taking only single term because of the simplicity of the calculation. Since the sum will satisfy the homogeneous equation, so the individual term will also satisfy the homogeneous equation. So that is why we are substituting only the individual terms. So a zeta to the power n exponential square root of minus 1 beta I h, where beta was mh by n pi. So beta was mh by n pi. As I have already told that beta was mh. So here I. So here since I is there, so ih by n pi. Let me check it. Yes, rh by n. Sorry, this is wrong. So beta was r pi by nh. This was your beta. Yes. So just substitute this into this. We'll get what we'll get. Let me write here. So we'll get a zeta n plus 1. Okay, so a zeta n plus 1 exponential square root of minus 1 beta IH, so IH will be only there, IH, so n plus 1 IH, this would be equals to A or A zeta to the n or A zeta to the n exponential square root of minus 1 beta IH or I minus 1h, yeah, I minus 1h plus 1 minus 2r A zeta n exponential minus square root of 1 beta IH plus r into A into zeta n exponential square root of minus 1 beta I plus 1 h. Okay. So again we will cancel this A will be cancelled, zeta will be cancelled, so only single zeta will remain. So here single zeta and this I will be cancelled, equals to r zeta will be cancelled, so I minus 1 is there, so this will be exponential square root of minus 1 beta minus 1h plus 1 minus 2r, zeta will be cancelled, so this A will be cancelled, plus r exponential minus 1 beta h. So again if we club this term and the last term, so this is nothing but r exponential square root of minus 1 beta h plus 1 by square root of minus 1 beta h. So this will be 2r cosine beta h. So this will give me 2r cosine beta h plus 1 minus 2r. So this is my J. Again what we want, mod of xi should be less than equals to 1. So mod of xi should be less than equals to 1. So this will give me mod of 2r cosine beta h. So this I can further simplify. So this I can further simplify that if I take 2r common, so it will be cosine beta h minus 1 plus 1. So cosine of beta h plus minus 1 means cos 2 theta minus 1 will be, let's recall this. So cos square theta will be cosine, cosine 2 theta, cosine 2 theta will be cos square theta minus sin square theta. So if I write cosine 2 theta, this I can write 1 minus 2 sin square theta. So this would be cosine 2 theta minus 1 will be minus of 2. So this will be, so cosine 2 theta minus 1, this will be minus 2 sin square theta. Yes. So this I can write minus 4 r cosine beta h by 2 plus 1. Or we can just do the calculation from here, and just after doing the calculation, if we do this, so we what we have now, let's write it once. So we have 1 minus 4 r, sorry, it's sine now, yeah, it will be sine square beta h by 2. Yes, yeah. So 4r sine square beta h by 2, this mod has to be less than equals to 1. So again you consider once you plus minus r, and you will get if you consider this, again we will get r is lies between 0 to half. This, and hence this method will stable only if your r would be from 0 to half.